Alright, so we'll be doing problem number 3, part A, where we're asked to draw an arrow indicating the direction of the magnetic force delta F3(1) on a piece of wire 3 of length delta L due to the current in the wire 3 and 1 only. Based on the symmetry, draw a second arrow indicating the relative magnitude and direction of the magnetic force delta F32, the magnetic force on a length of wire 3 delta L due to the current in wires 2 and 3. Okay, so probably the biggest problem with this question is actually interpreting what it's asking you to do. There's a lot of complications here. You could easily think that it was asking you to draw an arrow of the magnetic force of 2 due to 1, or vice versa, or you might miss the keyword that it's 3 delta L, so it's very important to read the problems very carefully here. So first, we'll find the magnetic field due to wire 1 on wire 3, or the direction of it, because all we're concerned here is really the directions and the relative magnitudes of delta F32 and delta F31. Okay, so first of all, we can use the right-hand rule where, like, since this current's pointing into the page, we curl our fingers in the direction of the way our fingers curl is in the direction of the magnetic field here. So we can see that the magnetic field would be pointing in this direction approximately, which means that then we take the current, because F is equal to IBL, so we can take, or it's approximately like I delta L cross B, and we can take the current and then we'll cross with that, and we see that this is an attractive force. When currents are running in the same direction, the wires are attracted to each other by the magnetic force. So we'll just draw delta, or delta F3, 1 here, pointing towards that wire since it's an attractive force. And then we'll do the same for this wire. We see that the magnetic field will be approximately pointing this way. And then, well, actually, let's see, points more so to probably that way. And then, or we can just use the symmetry here essentially, and the arrow delta F2, 1 will be pointing also to this wire. If we just use the right-hand rule, we find that the magnetic field is pointing that way. Oh yeah, it's I cross B. So we take this and then we cross with B, so it's pointing down towards I2, another attractive force. It's easy to get confused, and then we also see that since this is technically 3 delta L, so instead of just delta L, we know that this should be 3 times longer. So technically, if we want to keep the relative magnitudes exact, we can like make this 3 times longer. Alright, so yeah. And then if you want to adjust this problem, you can have different orientations, maybe not the z-axis and or the x-axis, make them oriented slightly differently, maybe make them point towards each other and see what that does, or like have a few of the wires pointing out of the page or into the page and see how that impacts the force.